Hello again. So, next one on this is the epsilon n proof. And then I might have to call it because I've got a thing coming up. Hopefully I'll see you there. It's the talk coming up in 20 minutes. For me anyway. Epsilon n proof. Claim if an is a sequence which converges to 1, then an squared converges to 1. And here I do want to emphasize this idea of coming up with a proof again. So, I'm not going to try to be like super clean with what I write right now. This is just scratch walk. So, an is a sequence which converges to 1. Right, you throw out all of the quantifiers. There's my goal. An squared. An squared converges to 1, so there's my goal. That's what I want to get. The thing I get to know is absolute value of an minus 1 is less than, and I can put any damn thing I want in that box as long as it's bigger than 0. I guess it also has to be like independent of n, but that's fine. So let's see what we can do. So I'll look at the goal. This thing that I want to show to be small, if I can get it in terms of this an minus 1, then like that'll be helpful. Maybe here's the mindset I'll take. This looks like a difference of squares. Let's start with that. This isn't the only way to shake this particular stick. Oh, that's good. There's something that I just know is small. So let's pull that out and see what we can do. All right, so far that's where we are. And you might think to yourself under this situation, well, let's just set this equal to epsilon and solve. So this is what I'm doing right now is bad. And we'll wind up with blue box equals epsilon over absolute an plus 1. And here's why this is bad. That depends on little n. Epsilon is not allowed to depend on little n, and we'll talk about why when we write down the proof. It's allowed to depend on epsilon, and that's about it. Okay, well, so that's no good. But like, an plus 1 absolute value isn't that complicated. In fact, I bet we can get this to look like an minus 1 by doing like a minus 1 plus 1 trick. Equals thing in a box times absolute value an minus 1 plus 1 plus 1. And I just inserted a minus 1 and a plus 1. Ooh. So now I see an an minus 1. There's something that I know I can get small. And there's just 2. So what do I get? I get box times an minus 1 plus 2. Anyway, one thing you could do, let's make that get out of here. One thing you could do is like now set this equal to epsilon and solve that for box. You'd have to solve like some quadratic equation. It'd be annoying. So I'm not going to do that. Instead, here's what I'm going to do. This thing already is as small as I want. So let's let this box deal with making it small. This box, I'll just put something in it. So let's demand that the absolute value of an minus 1 be less than 1 and less than something else. So that's now going to give me box times 1 plus 2 is 3. I can set that equal to epsilon. So what I want in the box is, it looks like epsilon over 3. All right. So it looks like I need to have an minus 1 be less than 1 and be less than epsilon over 3. Well, you know what that means. I need to be less than the min of 1 and epsilon over 3. All right. We have our idea down. Let's write the proof. Proof. So what do? We get to assume an is one too many s's. Is a sequence, and an converges to 1. It's nice to have this little shorthand so you don't have to say converges to so often. We will now consider any epsilon bigger than 0. Over here in the scratch walk, we figured out what we need to have in the box. We need an minus 1 to be less than that positive number. So let's do that. Since an converges to A and min of epsilon over 3, comma 1 is bigger than 0, it follows that there is some big N, so that for all little n bigger than big N, absolute value an minus 1 is less than, I can put any positive number I want down, but because of the scratch work I did, I know that the min between epsilon over 3 and 1 should do the job. And maybe I'll do a quick sanity check. Why is the min of this thing bigger than 0? Well, 1 is bigger than 0. Epsilon over 3 is bigger than 0. So since both of those things are bigger than 0, whichever one is smaller is bigger than 0. All right. So now let's let little n be bigger than big N. And maybe I'll even stir this a little bit so I can fall back to it later on. Let little n be bigger than big N. Then absolute value of an squared minus 1. And now I'm going to lean heavily on the fact that I already know what I'm supposed to do. Difference of squares, property of absolute value. An squared minus 1 in absolute value is equal to absolute value an minus 1, an plus 1, by I guess this is the difference of squares. Is equal to the absolute value of an minus 1 multiplied by absolute value an plus 1. That minus 1 looks like it's in the subscript, which it is not. By properties of absolute value. All right, and what did I do over here? Well, I put a box here and said it was less than that box. What's the thing I needed in this box? It was epsilon over 3. It is less than epsilon over 3 times absolute value an plus 1. And now I'm going to go out of this like math mode tower to write a sentence. This follows since little n is bigger than big N, so absolute value of an minus 1 is less than or equal to min epsilon over 3, comma 1 by star. That star, now lets the reader know that I'm referring to this stuff right here. All right, cool. Let's carry on from there. by adding and subtracting 1. Subtracting and adding 1, what do we get? We get an plus 1 is equal to the absolute value of an minus 1 plus 2 by the triangle inequality. Oh, I guess that straight mark works out okay. Inequality. Absolute value an plus 1 is less than or equal to absolute an minus 1 plus 2, and that's less than or equal to 3. Well, maybe I'll put that on its own separate line. Since little n is bigger than big N, we use star, which I've done an orange so far, so let's leave it, to see absolute value an plus 1 is strictly less than 3. An plus 1 is less than or equal to an minus 1 plus 2. Little n is bigger than big N, so we get this conclusion. An minus 1 in absolute value is less than 1. And it looks like I'm going to default to this line now, so let's indicate it. Combining this with triangle, absolute value of an squared minus 1 is less than epsilon over 3 times absolute an plus 1 is less than epsilon over 3 multiplied by 3 is equal to epsilon. And now let's write a good strong conclusion. Thus, for all epsilon bigger than 0, we have produced a big N so that for all little n bigger than big N, absolute value of an squared minus 1 is less than epsilon. Therefore, an squared converges to 1, as claimed. Groovy. So hopefully this bunch of things gets posted by like the end of the night tonight, but maybe it won't. Depends on how my internet is at home. We'll get more of these recorded over the weekend and posted up in advance of the start of the week. Wonderful. Hopefully I'll see you all maybe in the next 6 minutes in this talk that's happening. Ciao, ciao.